Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A team deploys a VM with a cognitive services key baked into a config file. A misconfigured network security group leaves RDP open. An attacker breaks in, finds the key, and within hours the entity recognition endpoint is being hammered. Because it's a multi-service key. A single secret that gives full access to every AI service under one account. Every API, from language to speech to translation, and even OpenAI is available. The bill runs into thousands before anyone notices. That key never should have existed in plain sight, and by the end of this video, you'll know how to eliminate keys entirely and build a managed identity foundation that prevents exactly this kind of disaster. Here's what you'll walk away with. First, disable key authentication on an AI services account using the Azure portal. Second, authenticate a container with a managed identity so no secret ever touches your code. Third, explain why multi-service keys are a security risk. One leaked key can compromise all your AI APIs. Let's build it step by step. So what is a resource key really? It's a static string that Azure gives you, full privilege by default, and you send it in a header called OCP APIM subscription key. There are 2 keys per resource. That's so you can rotate one while the other stays live, which is a great idea that almost nobody actually executes. The key remains valid until you explicitly rotate or regenerate it. There's no automatic expiration. And if you're using a multi-service account, that one key can call language detection, sentiment analysis, speech-to-text translation, and even OpenAI chat completions. The blast radius is enormous. A single leaked multi-service key can send your API costs through the roof. Baseline operations might cost a couple thousand a month, but an attacker with an unrotated key can drive costs to tens of thousands before you even notice. Because there's no expiration and you're billed per call, the damage multiplies fast. This isn't theoretical. Static credentials left exposed have caused massive cloud bills. Let's put the 2 side by side. On the left, a shared key. The secret lives on disk, rotation is manual and usually forgotten. Access control doesn't exist. Anyone with the key gets everything. And audit logs show generic key-based access with no user distinction. On the right, a managed identity. No secret stored anywhere the app can touch. Azure rotates the certificate for you. Access is controlled by role-based access control, RBAC, and every call is tied to a specific identity in Microsoft Entra ID, Azure's identity platform. The choice isn't even close. Quick checkpoint on what we just covered. What's the single biggest security advantage of using a managed identity over a resource key? Pause and think. The answer: there's no static secret to steal, commit, or rotate. Azure handles tokens behind the scenes through Entra ID, so your code never touches a credential. Compare that to a key you have to protect, rotate, and never accidentally push to a repo. Before we eliminate keys for good, lock in those differences. Quick checkpoint. What are 2 differences between shared key authentication and managed identity? Pause if you need a moment. Here's the answer. First, a shared key is a static secret you must protect and rotate yourself, A managed identity has no secret. Azure handles the credentials. Second, a shared key gives total access to whoever holds it, while a managed identity uses RBAC so you can limit exactly what it can do. That contrast will protect your next deployment. A managed identity comes in two flavors. System assigned is tied to a single Azure resource and gets deleted with it. User assigned is a standalone identity you can attach to multiple resources. Behind the scenes, Azure provisions a certificate for the identity. Your code never sees it. When your code calls DefaultAzureCredential, it reaches out to the local metadata service at 169.254.11.69.2.54, gets a bearer token, and attaches it to the request. There's no config file, no environment variable, no key vault entry for the credential itself. An attacker can't steal what was never stored. First command, create a resource group. Think of a resource group as a logical container that holds every component you're about to deploy. The name RGAI102CA2 ties it to this chapter, and the location Eastus places the metadata in the East US region. Expect a JSON output with provisioning state succeeded. That's your green light. This single container will later let us delete everything with one command when we're done. You can also create the account through the portal. Click Create a Resource, search for AI Services, and choose the Multi-Service Account option. Give it a globally unique name, select your resource group and region, and pick the standard S0 tier. Click Review and Create, and Azure provisions the same multi-service endpoint we just built with the CLI. Before we run this, ask yourself, how many times have you left a key in your terminal history? This is the last time. Here's the quick start trap in live code. We fetch key from the CLI, then use curl with the OCP APIM subscription key header. The Language Detection API returns a JSON result with the detected language and confidence score. It works instantly. But that key is now sitting in your shell history, and if you had committed this code, it would be in your repository forever. That's why the very next line is crucial. We immediately unset key 1 to scrub it from the environment. Think of this as the before picture. From here forward, we'll never type a key again. Here's the fast way to kill key auth completely. In the portal, open your AI Services resource, go to the Keys blade, and switch from the default key-based access to role-based access control. Hit Save. That's it. API keys are now dead with this resource, and only Microsoft Entra ID works. No more keys to leak. Let's verify the token flow. Quick checkpoint. What local endpoint does the container hit to get its first bearer token when using a managed identity? Pause. The container calls the Azure Instance Metadata Service at 169.254, 169.254. That's the IP that only local workloads can reach. It requests a token scope to cognitive services. Entra ID signs a short-lived JWT, and the container passes it as a bearer header. No static secret anywhere. Let's lock in the keyless recipe. What 3 steps make keys disappear? Pause and recall. Step 1. Disable local authentication so only Entra ID is accepted. Step 2. Enable a managed identity on your container or app. Step 3. Assign that identity the Cognitive Services user role on the AI Services account. No API key. Follow that, and you've removed the most common credential leak vector in Azure AI. The keyless setup follows a 3-step sequence. Step 1. Disable local authentication so only Entra ID is accepted. Step 2. Enable a system or user-assigned managed identity on your compute resource. Step 3. Assign that identity. The cognitive services user role on your AI services account. No API key in sight. Follow these, and you've eliminated the most common credential leak vector in Azure AI. Authentication is solid, but let's lock the door physically. We create a virtual network and a subnet, then deploy a private endpoint that injects our AI Foundry account into that network via a private IP. Next, we set up a private DNS zone for privatelink.cognitiveservices.azure.com. Link it to the VNet, and add an A record so that when any resource inside the VNet resolves the cognitive services hostname, it gets the private endpoint's IP instead of the public one. Now, even if a bearer token somehow leaks, the attacker must be inside your VNet to reach the endpoint. Public internet access is severed. Combined with managed identity, you've built a credential-free, network-isolated AI service that blocks common risks like server-side request forgery and unintended key leakage. One final recall checkpoint. We spent most of this video replacing keys with managed identities, then locking down network access. What's the single biggest advantage of that identity-based approach? Take a moment. The answer is coming. Let's take stock. You just built a production-grade authentication foundation for Azure AI, a multi-service cognitive services account with key authentication disabled, a container that authenticates entirely through its managed identity, Python and function code that works identically on your laptop and in the cloud without a single if-else, and a network boundary that keeps the endpoint invisible to the internet. Every future piece of the Contoso healthcare pipeline, document extraction, radiology image analysis, patient form processing, will stand on this identity stack. No more key rotation spreadsheets. No more we'll rotate it next sprint. You've got the blueprint. In the next video, we'll harden this further with identity, networking, and governance controls that turn your AI service into a fortress. See you there. Your keyless foundation is ready.